The Tesla Model 2 has officially arrived, and Tesla just confirmed 7 exterior upgrades included at zero extra cost. Every buyer gets them standard: dust-repelling wheel arches that cut mud buildup by 80%, heat-reflective coating that drops cabin temperature by 7 degrees, and self-cleaning underbody sensors that slash maintenance costs by $300 over 5 years. These aren't marketing gimmicks. Tesla's internal testing shows real performance gains: 2 to 4 decibel noise reduction, 85% less sensor dust accumulation, and measurably cooler interiors. So here's what's interesting. Why is Tesla giving away upgrades that traditionally cost thousands as premium add-ons? Let's start with the most practical upgrade that directly impacts your wallet. Tesla developed a wheel arch system using a hybrid polymer with a friction coefficient of just 0.05 to 0.12. That's 3 to 6 times slicker than standard wheel liners. The material combines silicone elastomer with a wave pattern structure inside the arch that creates mechanical oscillation above 35 miles per hour, essentially shaking off mud and snow automatically. Real-world testing shows mud buildup drops 60 to 80%, and snow accumulation decreases 70 to 90%, which means you're cutting underbody wash frequency from 6 times yearly to just 3 or 4. Over 5 years, that saves several $100s when you factor in reduced damage to mud flaps and sensors near the wheel housing. The polymer maintains its dirt-repellent properties down to minus 40 degrees Celsius and withstands 200 hours of vibration cycles, simulating 2 years of operation. So here's what's interesting. Why would Tesla develop something this sophisticated and then give it away standard? What does that tell you about their actual production costs versus what legacy automakers charge for similar protection? This philosophy of solving problems before they happen extends to how the Model 2 handles security. Instead of just recording incidents after they occur, Tesla integrated ultrasonic sensors effective within 1 to 2 meters and short-range radar that differentiates risky movements from normal traffic. When both sensors confirm an approaching object, LED strips around all 4 sides activate at 20 to 60 lumens, bright enough to illuminate without causing glare for pedestrians or other drivers. The system draws under 0.8 watts per activation, so overnight battery drain is negligible. Tesla's internal testing reveals a 35 to 50% reduction in incidents like attempted door opening, minor impacts, and charge port tampering in low-light parking areas. The psychology is straightforward. Unexpected illumination interrupts undesirable behavior immediately. Each zone activates independently, meaning if someone approaches from the rear, only rear lights engage rather than lighting up the entire vehicle like an overreactive alarm. The efficiency here is impressive, but there's a deeper question. If this technology genuinely cuts security incidents by half using existing sensors, why aren't other traditional automakers implementing it? Is the integration too complex for manufacturers still working with fragmented supply chains? The answer might lie in Tesla's willingness to trust passive systems over active ones, which becomes clear when you examine their thermal management approach. Traditional EVs use motor-driven active grills that require maintenance, accumulate dust, freeze in winter, and eventually fail. Tesla eliminated all moving parts from the Model 2's cooling system. Ultra-thin air channels built directly into the front fascia compress incoming airflow at highway speeds, creating natural pressure differences that push cool air downward toward the battery pack. No motors, no failure points, just physics working continuously whenever you drive. Battery temperatures drop 4 to 6 degrees Celsius at high speeds, and every few degrees of cooling slows cell degradation while helping maintain capacity over years of use. The active cooling system saves 2 to 3% energy because it doesn't have to compensate as aggressively. Over thousands of miles, that small percentage compounds into meaningful range extension. What's radical here isn't the technology itself, it's Tesla's confidence in shipping a design with zero mechanical backup. This trust in elegant engineering solutions continues with the exterior coating, which uses nanoparticle structure to reflect infrared radiation before it can heat the metal body. When direct sunlight hits, these nanoparticles bounce infrared energy away instead of letting it absorb into the vehicle. Surface temperature drops 12 to 18 degrees Celsius in strong sun, keeping the interior 4 to 7 degrees Celsius cooler after equivalent parking time. The infrared reflectivity ranges from 60 to 75%, which is 2 to 3 times higher than traditional automotive paint, reflecting only 10 to 25%. The coating also limits surface fading and aging because it blocks harmful heat energy before degrading the finish. For vehicles parked outdoors daily, this extends exterior durability significantly without requiring ceramic coating or paint protection film. But consider what this means for positioning. Tesla developed aerospace-grade thermal management for a mass-market vehicle and made it standard equipment. How does that change your perception of what affordable EV actually means? The thermal strategy becomes even more sophisticated when you look at the window technology. The Model 2 uses electrochromic material that changes molecular structure when a small electric current passes through, shifting from clear to dark in 0.6 to 1.2 seconds. UV blocking reaches 92%, infrared reduction hits 65%, and combined with the reflective coating, cabin temperature stays 5 to 8 degrees Celsius cooler during peak sunlight. The transition speed matters because older tint technologies cause discomfort with slow, noticeable changes. This system responds fast enough that your eyes never register the shift as jarring. Users don't need aftermarket tint films that degrade after 2 to 3 years, peel at the edges, and often violate local regulations. Dynamic privacy tint remains stable indefinitely with no discoloration, while reduced UV penetration protects seats, dashboard, and interior surfaces from fading. The question worth considering, if this technology has been available for years in vehicles costing twice as much, why did it take Tesla to make it standard on an affordable model? What are established manufacturers protecting by keeping it as an expensive option? The same pattern of solving everyday frustrations shows up in how Tesla redesigned the charge port. Most EV owners accept a common problem as normal: walking up to your car in a parking lot, unsure if it's actually charging or if something went wrong. Tesla added a semi-transparent LED ring divided into 4 zones around the entire port, displaying fast charging, slow charging, CCS error, or fully charged status with gentle motion effects. Brightness ranges from 80 to 120 nits, visible even in daylight, while consuming under 0.5 watts. Real-world testing shows users can check charging status from 3 to 4 meters away in outdoor lots or low-light areas, which reduces the chances of unplugging too early or forgetting to charge fully, situations that create range anxiety and disrupt daily schedules. The implementation requires no additional app notifications, no squinting at tiny indicator lights, just instant visual confirmation from anywhere nearby. Would you have thought to request this feature before experiencing it? That's the difference between asking customers what they want versus observing what actually frustrates them. Perhaps the most technically impressive system addresses a problem most owners don't even know exists until their FSD sensors start malfunctioning. Tesla designed an underbody airflow system that directs air through specialized channels, slightly compresses it through the Venturi effect, and blows it directly at sensor locations beneath the chassis. The system activates automatically above 40 miles per hour and reduces dust accumulation on underbody sensors by 85%. For FSD operation, this matters significantly. Sensors covered in dust, gravel, or road debris can't maintain the accuracy required for autonomous driving features. The technology saves an estimated $200 to $300 in sensor maintenance over 5 years, but the benefits extend beyond direct costs. Mechanical and electronic components beneath the vehicle experience less abrasion because contaminants are continuously cleared away. Tesla's simulations indicate that removing 80 to 85% of debris reduces friction and mechanical impact on underbody parts, extending component lifespan by 15 to 20%. The system demonstrates that aerodynamic principles can replace mechanical cleaning systems entirely while consuming zero electrical power. How many owners even realize their FSD sensors are being actively protected every time they drive on the highway? What connects all 7 upgrades reveals Tesla's actual strategy. Not one system requires significant ongoing maintenance, complex repairs, or proprietary service procedures. The DustGuard polymer lasts years at extreme temperatures. The Sentry lighting uses standard LEDs. The ventilated fascia has no moving parts. The reflective coating is permanent. The dynamic tint has no mechanical components. The charge port LEDs are solid state. The underbody cleaning uses air pressure. Tesla engineered every system to function reliably without creating future service revenue opportunities. Traditional automakers design premium features that eventually need replacement, recalibration, or dealer service. That's how they maintain profit margins after the initial sale. Tesla's doing the opposite, building in durability that reduces their own service income potential. The reason becomes clear when you step back. They're not planning to make money from maintenance. They're planning to make money from the software and energy ecosystem these vehicles connect to. Every Model 2 on the road becomes a node in Tesla's charging network, a data point for FSD development, and a potential subscriber to future services. The 7 exterior upgrades aren't generous gifts. They're strategic infrastructure. Tesla needs these vehicles to last longer, require less service, and stay operational more consistently than any competitor's product. Lower maintenance costs drive higher owner satisfaction, which generates positive word-of-mouth and repeat purchases far more effectively than traditional advertising. Does this change how you view what Tesla's actually selling here? So here's what these 7 free upgrades actually reveal. Tesla isn't just building electric cars. They're engineering an ecosystem where vehicles require minimal maintenance, last longer, and perform more consistently than anything from traditional automakers. The dust-repelling arches, self-cleaning sensors, heat-blocking coating, and passive cooling systems all serve one purpose: keeping Model 2 vehicles operational with almost zero service requirements. That's not generosity. That's Tesla building a foundation for long-term market dominance through reliability and owner satisfaction. While other manufacturers still profit from maintenance schedules and dealer visits, Tesla's betting everything on vehicles that just work year after year. And if they're implementing this engineering sophistication in their most affordable model, what's coming next from their design teams will completely redefine what we expect from transportation. What do you think this means for the traditional auto industry in 5 years? Drop your prediction in the comments below. If you want more deep dive analysis on Tesla's actual engineering strategy, hit that subscribe button for Tesla Zone and turn on notifications so you never miss our breakdowns. And if this changed how you see the Model 2's value proposition, leave a like. It helps more people discover content that goes beyond surface level coverage. The automotive revolution isn't slowing down. It's accelerating.